Let us see some more interesting property related to mean term and max terms. So the first one we have understood, the second one we have understood, right? So now let's see first the fourth one and then I'll explain the third one, then the remaining two. So this says using n variables we can have at max 2 power n number of mean terms. Using n variables we can have at max 2 power n number of max terms. So we have seen in the previous video, students, like if I have a function of, let's say, 3 variable a, b, c, total how many number of combinations possible? There are 8 combinations possible, 8 combinations. So let's say if I am saying that out of 8 combinations, 3 combinations are mean term. So that means what? The remaining 5 are max terms. So if you add the number of mean terms and number of max terms, so it is always 2 power n. I mean, it's a 3 variable case, 2 power 3. So in general, sum of number of mean terms plus sum of number of max terms is always equals to 2 power n. So suppose somebody asks you, at max, how many number of mean terms you can have? So the simple logic is, if all the 8 combinations, if it will contain logic 1, I'll have maximum number of mean terms. Or let's say if I'm going with a 2 variable case, let's say a and b, I'm going with a 2 variable case, the output is y. So how many combination possible? 2 power 2, 4 combination possible. So the question is, how many mean terms possible at max? So you make all the outputs as 1. If you make all the outputs are 1, so there are total 4 combinations and all 4 are mean terms. So in this case, you have maximum number of mean terms. And so that means in general, I can say that in 2 variable case, at max, I can have 4 number of mean terms. When is it possible? When all the input combinations are producing output 1. In a 3 variable case, at max, how many mean terms possible? 8. Because in a 3 variable case, you have 8 number of input combination. And if 8 input combinations are producing 1, you get a maximum number of mean terms. So in general, using n variables, we can have at max 2 power n number of mean terms. Similarly, if I ask you the case of max terms, so then simple logic, you make all the outputs are 0. Suppose all these outputs are 0. That means that is fine. So in 2 variable case, at max, I can have 4 max terms. In a 3 variable case, I can have at max 8 max terms. So that's why in general, using n variable, we can have at max 2 power n number of max terms or at max 2 power n number of mean terms. But simultaneously, it is not going to happen. If this is happening, then this won't happen. If this is happening, then this won't happen, because how the output can be 0 and 1 simultaneously? Not possible, right? So we understood what is the meaning of this, the fourth property. Now let me explain you the third property, students. What is the third property? Third property, this one. It says sum of all 2 power n mean terms is 1. This says product of all 2 power n max term is 0. So symbolically we write summation mi, where I ranging from 0 to 2 power n minus 1 is 1. Summation I equal to, the pi symbol, that is product of I from 0 to 2 power n minus 1 mi is equals to 0. So what is the meaning of it? So let us take the 2 variable case. So in the 2 variable case, so let me take one function y1 and let me take another function y2. Okay. I am selecting y1 in such a way that output is 1 for all combinations, and I am selecting y2 in such a way that output is 0 for all combinations. So this is the case, the extreme case I am going. So in y1, all combinations are mean terms. In y2, all combinations are max terms. So if I tell you, you define y1. So y1 is nothing but how much? Summation mean term 0, 1, 2, 3, right? So this is equivalent to mean term 0 plus mean term 1 plus mean term 2 plus mean term 3. So how do you write mean term 0 using AB? Because you are using 2 variables. 0, 0. 0 means 0, 0. This is 0, 1. This is 1, 0. This is 1, 1. So 0, 0, how do you write? You can write this is A bar, B bar plus A bar, B. Not to forget, in the mean term, every term will give me a product term, right? Mean term, every term will give me a product term. And here 0 is taken as variable bar, 1 is taken as variable. So wherever 0, I am writing variable bar, wherever 1, I am writing variable. And this is your A, B bar, and this is your AB. So from the first 2 term, let me take A bar common. Then you get it is B bar plus B. From the second 2 term, let me take A common, you get B bar plus B. So B bar plus B is 1. So you get A bar dot 1 plus you get A dot 1. So A bar dot 1 is A bar. A dot 1 is A, so A plus A bar is 1. A plus A bar is 1. So what is the conclusion then? So this is equals to 1. That means if I am taking a function where all the input combinations are producing output 1, that is the case of 2 power n number of mean terms. If I add all the mean terms, I get the answer as 1. Now, don't you think, students? So this can be written as summation I ranging from 0 to 2 power 2 minus 1 mi is equals to 1. So if I expand this equation, that this is how much if I expand this? This is I ranging from 0 to 3 mi equals to 1. Now if I expand this, don't you think I'm going to get this equation? Yes. So this is what the analysis what I have done now. So this is written here. So summation I ranging from 0 to 2 power n minus 1, because it is a two variable case AB, so it is 2 power 2 minus 1 mi equals to 1. So whenever all the combinations are taking output 1, then this condition is always valid. Okay, same story you can do for the Maxterm case. If I do for Maxterm case, student, here, if I do for Maxterm case, so here you can write the y2 as Maxterm how much? 0, 1, 2, 3. So this can be written as Maxterm 0 ANDed with Maxterm 1, ANDed with Maxterm 2, ANDed with Maxterm 3. 0 means 0, 0, 1 means 0, 1, 2 means 1, 0, 3 means 1, 1. So in Maxterm notation, 0 is variable, 1 is variable bar. So 0 is variable. So it is a plus b, it is a plus b bar, it is a bar plus b, and here it is a bar plus b bar. So let me take first two term as a bracket, second term as other bracket. So here the first variable are same. Answer is product of first variable plus product of second variables. So this answer is a dot a is a plus b dot b bar is 0. Similarly, in the next case, a bar dot a bar is a bar plus b dot b bar is 0. So this is a plus 0 is a dot with a bar plus 0 is a bar. So a dot a bar is equals to 0. So what is happening then? So this is equals to 0. So I can symbolically write this as pi symbol I ranging from 0 to 2 power 2 minus 1 mi is equals to 0. Right? So if you expand it, it is I ranging from 0 to 3 mi equal to 0. That is Maxterm 0 ANDed with Maxterm 1, 2, 3 is equals to 0. So this is what I have written. So product of all 2 power n Maxterm is 0. Sum of all 2 power n Minterm is 1. So this is what the meaning of this property. I hope this logic is clear to all of you students, right? So you may make a note of this. Now, the next property is this one. This is an important property. We'll be using this to solve some problem. So what this property says, students, is this property says that mean term I dot with mean term j is equals to 0 if I is not equals to j. So let us take example. Let's say mean term 7 ANDed with mean term 12 is equals to 0. I mean by this logic, because I is not equal to j. If I am using the number 12, that means I am going for the 4 variable case. Let us assume that this relation are written with respect to 4 variable case. So what is mean term? I mean, let's say the variables are a, b, c, d. So 7 means how much? 0, 1, 1, 1. 12 means 1, 1, 0, 0. So 0, 1, 1, 1 means a bar, b, c, d. This is mean term 7. And mean term 12 is a, b, c bar, d bar. Now you simply do the AND combination of these all. Don't you think the answer is 0? Yes, definitely answer is 0. Why? Because a bar dot a is 0 and 0 ANDed with anything is 0. Or even d bar is present. So d bar is 0, 0 ANDed with anything is 0. It makes sense, student, in a particular function, if I am selecting any two arbitrary number of different number, so definitely their bit pattern won't match. So if bit pattern won't match, it means that if you have a, there might be a bar, or if you have b, there might be a b bar. So the AND combination of variable and its complement is 0, and the overall AND combination will be definitely 0. So mean term I dot mean term j is always equals to 0 if the index are not same. But what is going to happen if the index are same? So in other words, so let's say instead of having this, suppose somebody says that what is mean term, let's say 12 with mean term 12. So this is also I'm making 12. So if I'm making this is 12, so this will also be 1, 1, 0, 0. So if it is 1, 1, 0, 0, so now this is a, b, c bar, d bar. Now you see this is a, b, c bar, d bar, a, b, c bar, d bar, and this is also a, b, c bar, d bar. So this is if you write in a, if you write it by rearranging it, so you get A dot A, you get B dot B, you get C dot C, you get D bar dot D bar. I mean C bar, D bar, D bar. A dot A is A, B dot B is B, C bar dot C bar is C bar, D bar is D bar. So what is AB C bar D bar? AB C bar D bar is nothing but again mean term 12 only. So mean term 12 added with mean term 12 is equals to mean term 12. So that is why it is written here mean term I ANDed with mean term I is mean term I. That means in this case, if I and j are of same index, you again get the same mean term. But if I and j are of different index, you get it is always 0. So product of any two arbitrary mean terms of different index are 0. Product of any two arbitrary mean terms of different index are always 0. So this logic is clear, I believe. So let us see what is its equivalent property with respect to maxterms. So in maxterm we have this one, right? So it says sum of any two arbitrary maxterm is always 1 if again I is not equals to j. But if I equal to j, then mean term maxterm I plus maxterm I is again maxterm I. To explain you this, so let me take one more page, or we can do here also, no problem. Yeah. I want to justify this relation, right? Okay. Now, again, let us go with a 4 variable case. Let's say maxterm 11 plus maxterm 14. So the property says it should be 1. Maxterm 11. What is the binary combination of 11? 1, 0, 1, 1. What is 12? 12 is 8, 4, 12 to 14. Yeah, this is the combinations. In maxterm, 0 is taken as variable, 1 is taken as variable complements. If I write its corresponding notation with respect to ABCD, so A bar plus B plus C bar plus D bar, this is maxterm 11, plus 1, 1, 1, 0. So that is A bar plus B bar plus C bar plus D. Okay. You see students, now you have B and B bar combination. B plus B bar is 1 and 1 anything, if it is odd, the answer is 1. So if you find this entire expression, this will be 1 because B bar is present, it is 1 and 1 or with anything is 1. Similarly, with respect to D bar also you can see the same thing because D bar plus D is 1 and 1 or with anything is 1. So it makes sense whenever you are selecting two different index, their bit pattern won't be exactly same. There will be one mismatch, like if it is 0, it is 1 here. If it is 1 here, it is 0 here. So when you are writing its corresponding notation with respect to variable, you are getting a variable and its complement and you are doing the OR of it. So it will be 1 and 1 OR with anything will be again 1. So two different maxterms, if we do OR combination, the answer is always 1. But what is going to happen if I am selecting the same index, that is maxterm 11 and this is also maxterm 11. If it is maxterm 11, you get this is again 1, 0, 1, 1. So A bar, B, C bar, D bar, then you get A bar, this bar will not come, then C bar and this is D bar. So now you have A bar is A bar, B and B is B, C bar and C bar is C bar, D bar and D bar is D bar. So this is what you are getting. And now if you find it's what the maxterm combination of this. So variable bar is 1, variable is 0, variable bar is 1, variable bar is 1. So you see this is again your 11. So maxterm 11 plus maxterm 11 is again maxterm 11. So if we add maxterm of same index, you get the same maxterm. If you add maxterm of different index, you get this logic 1. So this is what is your property, this one, the tip property. So there are 6 property, right? So 1, 2, 3, 4, 5, 6. So 5 property we have seen. Now let us see the 6th property, this property. So this property says that, so let me take it to other page and we'll see. Yeah, you see. So this property says mean term I complement is equals to max term I or max term I complement equals to min term I. That is complement of mean term is max term of same index, complement of max term is mean term of same index. What is the meaning of it? Suppose you select mean term, let's say 10. So by this property, mean term 10 complement is equals to max term 10. So how is it valid? So mean term 10, how will be writing, students? Mean term 10, 10 is 1 0 1 0. So if you write in the mean term notation, 1 is variable, 0 is variable bar. So A, B bar, C, D bar. You take its complement. By De Morgan's law, if you split it, so you get A bar plus B plus C bar plus D. So this is what you are getting. So this mean term 10, it was a product term. When you are taking its complement, you are getting a sum term. So the product term was indicating mean term. So mean term 10 complement. Now you are getting a sum term. This is indicating the max term. So if I am asking you, if this is representing a max term, what is its number? What is the index? So how do you get it? So in the max term notation, students, already we have seen variable complement is 1, variable is 0. So this is a sum term, variable complement is 1, variable is 0. So you get this 1 0 1 0. Now don't you think this is max term 10? Yes, it is max term 10. So mean term 10 complement is max term 10, or here you can see max term 10 complement will be equals to mean term 10. Or you can take any other index also, no problem. Let's say I'm taking here max term 15, not 50. Oh yeah, max term 15 you can take. So max term 15 complement is equals to mean term 15. That is what I want to tell. So 15 is 1 1 1 1. So if you write its corresponding notation, it is A bar plus B bar plus C bar plus D bar. So this complement, if you take its complement, you get A, B, C, D. So this is a sum term, it was max term, it's a product term, it's a mean term. Now A, B, C, D means it is definitely mean term 15. So max term 15 complement is mean term 15. Okay, so these are the property of this mean term max term. So I suggest all of you to memorize all these 6 property. So more or less in many situations we have to make use of it, right? So now let us solve is questions which is based on this. So the question is this one, yeah. So here, so this is the questions. Let me take a fresh page and we'll be solving it there. So this is the question. Okay, see, the question is, if f of ABC having mean term 1 4 6 7, which of the following are equivalent to f? So here f is given to me. This is mean term 1 4 6 7. We can write this as mean term 1 plus mean term 4 plus mean term 6 plus mean term 7. If f is 1 4 6 7, then f complement, if I ask you what are the complement, I mean the mean terms of f complements, so it will be those missing term. It will be 0, 2, 3 and 5. 0, 2, 3, 5. One simple logic, students. How you may think, how f having these mean terms, so f bar having how these things. See, f having these mean term 1 4 6 7, it means that I can say that it is having max term combination. What are the max term combination? 0 2 3 5. These are the max term. I told you already, if you know the mean term index, the missing terms will be max term. In a 3 variable case, if 1 4 6 7 are mean term, then 0 2 3 5 are max term. But if you write its corresponding truth table, students, what it means? So in 1 4 6 7 combination, your output is 1, and in 0 2 3 5 combination, your output is 0, because mean term means output 1, max term means output 0. Now if you take the complement, then 0 will be 1, 1 will be 0. Yes or no? That means for 1 4 6 7 you are getting 1. If you take its complement, then for 1 4 6 7 you will getting 0. Similarly, 0 2 3 5 these were producing 1. Sorry, 0 2 3 5 they are producing 0. So if you take its complement, 0 2 3 5 will produce output 1. Are you getting or not? In simple language, suppose this is ABC. If I write its corresponding combination, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. These are the 8 combinations, right? So for these all 8 combinations, so I am saying that f having mean terms 1 4 6 7 1 4 6 7. That means remaining are 0. So these are zeros. Now if I say you take f complements, so if you take complement of this, those will be 0, that will be 1, those will be 1, that will be 0. So 0 become 1, 1 becomes 0, 0 become 1, 1 becomes 0. So now if I ask you what is the mean terms of f, it is 1, 4, 6, 7. Max terms are naturally 0 to 3, 5. Now f bar, if you observe, those were max terms of f, they become mean terms of f bar. So max terms of f are 0 to 3, 5. That means those were 0. So those were 0 means those were max terms, they become mean terms. So these combination 0 to 3, 5, which were mean terms, which were max terms of f, now they become mean terms of f bar. So this is your f bar column, this is your f column. So the max terms of f are equivalent to mean terms of f bar. Or you can say this f bar can be written as, if I write in terms of max terms, it will be 1 4 6 7. 1 4 6 7. Now see how I am manipulating this. What is the question, friends? I want to check. So this function is equivalent to which of these 4? So in that aspect, I am doing the discussion. So I want to explain the concept by taking this example as a reference. So let us see now what is the analysis is. So we have seen that mean term I complement is equals to max term I, or max term I complement is equals to mean term I. So now let me make use of this one, and if I do it, so what is I am going to get? So this is your mean term 1. So mean term 1, you can write this as max term 1 complement plus mean term 4. I am using this property. Mean term 4 is max term 4 complement. So max term 4 complement plus max term 6 complement plus max term 7 complements. So if you see this, this is matching with D. So this expression is given in D. So this is equivalent to D. Okay. This is one thing we have seen. Now, if I ask you to write f bar, so f bar is mean term 0 plus mean term 2 plus mean term 3 plus mean term 5. F bar is mean term 0, 2, 3, 5. So this is what it is. So there is nothing wrong if I say f is f bar bar, because if you have f bar, if you take one more time complement, you can get f. So you have f bar as this quantity. If you take its complement, so it will be complement of mean term 0 plus mean term 2 plus mean term 3 plus mean term 5. So you see that complement of mean term 0, 2, 3, 5 is given in option A. So A is also representing the equivalent informations. Okay. Now let us do thing. So F is this one. Now let us apply the De Morgan's law. If I apply the De Morgan's law, so mean term 0 complement plus is dot mean term 2 complement plus is dot mean term 3 complement dot mean term 5 complements. So mean term 0 and with mean term 2 complement, and with mean term 3 complement, and with mean term 5 complement. Is it given any option? Yes. This is given option C. So C is also representing the equivalent things. Now what about the option B? So let us try this also. So F bar. So this F bar, if I ask you in terms of max term notation, it is max term 1, max term 4, max term 6, max term 7. Then F is F complement complements. So complement of this F bar. So it is M1, M4, M6 and M7. So definitely this is also correct. So that means this function F is equivalent to all of these 4. Okay, so this is one of the beautiful concept. So in decoder, some good question can be created using these all properties. So the same function F, it looks very simple like this or maybe like this, but the same data can be represented to confuse students in this particular aspects. All right, friends.